Hey, if you're struggling to find a functional rule with these 2 points, let me give you a quick tutorial on how to do it. So let's look at the situation. Grace makes an investment in a local company after she graduates from university. This company has seen tremendous growth. Grace plans on holding on to the investment for several years until it reaches $500,000. At that point, she will use the money to open a small bakery that she has always dreamed of about. After 4 years, Grace's investment is worth $186,624. After 8 years, Grace's investment is worth $386,983.53. So this situation may seem really complicated, but if you understand how to use the rule by figuring out how to find the equation using 2 points, make a graph of the rule, and even fill out a table so we can visualize what is going on, you will be able to find when Grace can start her own bakery. So step 1, find the functional rule with given 2 points. Okay, so to solve this problem first, we have to know how to figure out the function rule using 2 given points. Now let's see these 2 points. After 4 years, Grace's investment is worth $186,624. After 8 years, Grace's investment is worth $386,983.53. Since we know that the years are going to be the input and the investment value is going to be our output, or the result of the time passed, we can write these points as 4,186624 and 8,386983.53. But we also know that this is going to be an exponential function, so our parent function will be y equals ab to the power of x. And if we rewrite these points as the values of an exponential function, this is what we get. Now, so how do we solve this? We know that in algebra, we can only solve a system when there is only one variable, so we should eliminate the easiest variable to eliminate, which is a. Now, how are we going to do this? Since this is a function in the geometric realm, to eliminate a variable, we need to divide, and if we divide on one side, we need to do it to the other. So if we divide, this will happen. This is what we'll get. We know that b to the power 4 is equal to this value. Now to figure out b, we must figure out the fourth root of this value. So if we do this, this will happen. We'll get this as our b value. Now this number is too complicated, so let's just round it off to the 100th power. So we get 1.2 as our b value, or common ratio. So we can find the value of a by dividing 186,624 by this value. Then we get 89,999.9991628, or if we round it off to the whole dollar, then it is about $90,000. Now finally, we got our equation. Our fx equals 90,000 multiplied by 1.2 to the power of x. Step 2 is identifying growth and decay. So when we are graphing an exponential function, it is important to determine if it is a growth or decay. A growth, or appreciation, is when the value increases over time, so the graphing would look like this. For growth, the value of the common ratio should be greater than 1, since 1 represents 100%. Decay, or depreciation, will decrease over time, so the graph will look like this. For decay, the value of the common ratio should be greater than 0, but less than 1, since it represents a decrease in the percentage. For this situation, we know that this is growth, or appreciation, because the common ratio is 1.2, that is greater than 1. Step 3 is to use a function notation. When we're graphing, we need to use function notation, usually used in the form f of x. This means the function of the output when the input is x. Now, we're going to change this into function notation. We're going to enter f of x. Now we're going to figure out how to fill out a table using the function notation in this equation. Get out the table template from this little arrow. Select table. Now we see x1 inputs and y1 outputs. We're going to change this into function notation, our x and our output, f of x. When you enter the inputs into your table, you will automatically see the points of our equation being entered. So for example, like this. Step 4 is to frame and label the graph. And there are two factors to consider when graphing, which is framing and labeling. So first, framing. Now, why do we frame? The objective is to make it visually appealing and easier for the data to be observed to the reader. You click on this little monkey spanner icon over here, and you'll see restrictions for X and Y coordinates. Now you click on it and enter the range of the data and the domain that you want to observe. When you can see that the line goes right through the middle of the graph, then you know if you've succeeded in framing. Now let's move on to labeling. Now, why is labeling important? It lets us know what is the input and what is the output. So to label on Desmos, you have to go to the monkey spanner bar again. Then you'll see where you could enter the labels for the x-axis and the y-axis. Now, we know that the x-axis is the input, so let's enter our input, the time. And the y-input, which is the amount of money. Now that we can see, there are labels on the x and y-axis. Step 5 is to use a graph, table, and rule to solve. Now, let's figure out when the investment would reach its goal and thus Grace open her own bakery. First, we're going to use a graph to achieve this. Now, it's rather simple and easy. First, we know that the goal is $500,000, and we know that the money is the output, is the y value. So in Desmos, we're just going to go ahead and enter
y equals.
Then we get a line of when y equals 500,000. Now, how are we going to use this to find when the investment has reached its goal? We're going to use this by figuring out the point of intersection between fx equals 90,000 multiplied by 1.2 to the power of x and y equals 500,000. Now, we see here in this gray dot over here, we can see the intersection point very well. We can see that it takes 9.405 years for Grace to achieve $500,000, which is her investment goal indeed. Now let's try confirming this and using the table. Now, since 9.405 years is a pretty big number, we're going to go ahead and round it off to 9.41. Now let's try using our table to confirm if we have reached our goal. And how are we going to do this? Before, we have observed that if we enter our input value for x, then we'll automatically get the value of f of x, which is the money that we want to find. Now, we're going to enter, as we observed here, we can see it's 9.405 years. We're going to enter this into our table. Now we can see that this number is a number that is very close to $500,000. Now, unless we use logarithms, it is impossible to find when it exactly reaches $500,000. So we will round it up to about 9.41 years to get $500,000. So here, no, we have used the table to confirm that 9.41 years is actually correct in achieving $500,000. Now we're going to try confirming when the investment reaches the goal by using the rule. Now we know that 9.41 years is our x input. So in our equation here, we're going to change the x value to 9.41. Now this number, although there are more decimal places, is equal indeed to this number and is very close to 500,000. So now we have used the rule, the graph, and the table to figure out when the investment reaches the goal, which is about 9.41 years.